This is the ME416 Project 3 Pin-Fin Analysis by Tyler Ellsworth and Alexandra Morford.
The goal of this project was to compare temperature gradients calculated in Ansys and the one-dimensional heat transfer equations to see if the one-dimensional assumption for heat transfer, that is, temperature gradients occur only down a fin, is appropriate. 3 materials and 3 diameters were tested, and then the percent error between the one-dimensional approximation and Ansys temperatures at the end of the fin were calculated.
The one-dimensional heat transfer equation shown was run in MATLAB for a fin of 2 cm diameter to determine when it could be considered infinitely long. The test was run separately for copper, aluminum, and stainless steel because they have different conduction coefficients.
The plot of temperature difference between the air and the end of the fin is shown. This uses the one-dimensional assumption. The fin is infinitely long when there is no temperature difference between the end of the fin and the air. We chose to approximate infinite length as a temperature difference of 1/4 of a degree Celsius because we considered that to be essentially zero. The infinite lengths required are 0.25 meters for stainless steel, 0.81 meters for aluminum, and 1.27 meters for copper.
The aluminum results are shown. The plots have the same length scale but different temperature scales based on the min and max for each diameter. The minimum end temperature for the 2 cm diameter fin on the top is 20.20 degrees Celsius. For the 5 cm fin in the middle is 22.71 degrees Celsius, and for the 10 cm fin is 30.12 degrees Celsius.
The copper results are shown on this slide. The 2 cm fin has an end temperature of 20.24 Celsius. The 5 cm fin has a minimum end temperature of 23.08 Celsius, and the 10 cm fin has a minimum end temperature of 30.95 degrees Celsius.
The stainless steel results are shown on this slide. The 2 cm fin has a minimum end temperature of 20.20 degrees Celsius. The 5 cm fin has a minimum end temperature of 22.53 Celsius, and the 10 cm fin has a minimum end temperature of 28.62 Celsius.
The one-dimensional error calculations show that there is very little error between the one-dimensional assumption and the Ansys calculation for minimum fin temperature, which occurs at the end of the fin. The errors that do occur are at the largest diameter tested and in aluminum. In aluminum, the 1D approximation used a constant conduction coefficient, and the Ansys approximation for aluminum conduction coefficient was temperature dependent.
The largest diameter tested was not large enough to demonstrate 2D heat transfer. The errors were less than 3% between the one-dimensional approximation run in MATLAB and the Ansys calculation, which means for these parameters a 1D approximation is appropriate. A smaller fin temperature differential in Ansys, or a finer mesh, would allow 2D heat transfer to be tested in cross-sections of the fins in Ansys.
Any questions?